Deep for that
Yes.
answer. How deep
Right.
alert?
Okay. So this register is used for the communication purpose. Okay. So SCON is nothing but first we will go through the PCON. So PCON first is it's a power control device. In this register, 2 bits will be there. So it will tell whether the microcontrol is in ideal mode or power down mode. Okay. So in a I am ideal mode. So what it will do in the sense, the clock pulse which I am going to give to the ALU, that will be stopped, and it will stop the peripheral devices like timers and interrupts. So timers will be there surely in the 8051 microcontroller, and interrupts will be there. So in a idle mode, by stopping the clock pulse, it will stop every action. So it will won't do any other action. So that is why it is called as a ideal mode. So PCON registers having the two modes. One is the ideal mode and another is power down modes. So if you give a ideal mode, in the sense the clock pulse will be stopped, and the interrupts, the timers, so serial interrupts and that, it won't work. So that is an ideal mode. And if you go for the power down mode, so in order to save the power, so if suppose the microcontroller is not doing any action, so what I will do in the sense, I will reduce the power supply. So usually the power supply has to be give for 5 volt, so in order to operate the microcontroller. But in power down mode, I will reduce the power to from 5 volt to the 2 volt, so that I can able to stop the microcontroller, as well as it will use it for a resetting purpose, the hard reset. So instead of giving the entire 0, so I will give the low voltage so that it will go to the reset mode. Okay. So that is the purpose of PCON registers. And so SCON is nothing but the serial control. So serial control, just now I told there will be a different baud rate. The speed of operation can be vary. So that can be controlled by your the serial control register. So that is named as a SCON. And as well as the SCON register is used for sending and receiving the data. So when I want to send and when I want to receive the data. So in order to enable the transmission and reception purpose, I will use the SCON, serial control register. So these are the two registers which I will use for communication purpose in the microcontroller. And as well as the buffer, the serial buffer is there. So that is used to store the data. Why? Because I'm going to send the data in a serial manner. Okay. So serial in the sense, surely I don't want to wait. So I will make a queue. So you know what is a buffer? So buffer is nothing but the temporary storage. So immediately I can able to access the value which is available in the buffer. Suppose if I want to access the memory, I want to ask permission from the microcontroller and I want to search the address. From the address, I want to take the data. Instead of that, I will fetch the data which is available in the memory, that will be fetched into the buffer, so that immediately I will transfer the data one by one. So suppose one data is transmitting. So during that transmission process, uh, at that time itself, another data will be loaded into the buffer. So again, I will take that data. So you can able to observe this practically in a YouTube. So buffering. So what is the buffering actually? So when you enable the video, so if you play the video in the sense, one by one, it will try to store temporarily. So once you completed watching the video, that memory, I mean, that data will be erased. Okay, so you can able to clear the that kind of data using clearing the caches in your mobile phones. So everywhere you are clearing the cache, right? So it's representing there will be a storage of your temporary data. So that will be clear. So that temporary data will be stored in your the buffer. Okay. So these are the registers which I am using for transmission purpose. Okay, so next here they shown some the standard, so baud rate standard, so it will be double the value. So minimum value should be 1200 and maximum it may go 9600. And So if you see, always it will be double the value. So how the data memory size will be calculated? So it will be calculated like 1 MB, 2 MB, 3 MB likewise. And if you go further, 1024 MB is equal to 1 GB, right? So after that, if you want to purchase a RAM, whether you can able to purchase a RAM in terms of 1 GB, 2 GB, 3 or 4, is that the case? No, right? So it will be doubled. So 1 GB, otherwise you will go for the 2 GB, otherwise you will go for the 4 GB and 8, 16. So the data will be like this only. So in a computer, so it will be multiplied. So as well as the bit, so number of bits will be a 8 bit or 16 bit or 32 or a 64 bits. So in between value won't be available. So here also the baud rate, there will be a standard baud rate. So it will be like multiples of 1200 and so on. Okay. And so I will use another mode of operations, serial mode. So in that registers, I can able to double. I mean, can able to set and double the data rate. So these are the registers which is used for serial communication. Just take a 8051 microcontroller. Just go to the registers, so which you already studied in MPMC. So just check at the registers. What is the SCON? What is the PCON? What is the S mode? Actually, these are the important one. So you could have studied, but you are telling and it's not taught that much deeply. I don't know. Next, the transmission and receiver. So how it will transmit and how it will receive. So we will see that. I told that it works on asynchronous and synchronous communication. So we have to set whether the transmission and reception should be made using the asynchronous and synchronous communication, and as well as you have to make the communication. I require the interrupt. So interrupt is nothing but so processor will do some work. So I want to transfer the data in the sense I want to ask the permission. I will request, I will request the permission. Once the microcontroller given the acknowledgement, then only I will make the communication. So likewise, the transmission as well as the reception also. So simply it won't receive. So it required the interrupt control. So interrupting the processor, and then I will complete the task. The transmission or reception, I will do it. So next, so transmission of data. So transmission of data, yeah.
சார் எனக்கு பிபிடி காட்ட மாட்டேன் சார். ஒயிட் கலர் போர்டு மட்டும் ஒயிட் கலர்ல தான் சார் தெரியுது.
Everyone, guys, can you able to see the PPT? Others? Because எனக்கு visible இருக்கு. Is it visible?
3 minutes அப்படிதான் சார் இருக்கு. ரொம்ப ஒயிட் கலர்ல அப்படி இருக்கு சார். கட் பண்ணிட்டு வெளியே போயிட்டு வந்தாலும்.
Others, can you able to tell whether the PPT is visible?
Yes, sir.
For all the students, it is visible white. Only one told remaining. Whether I want to know whether it is my problem or the student's problem. Others, please respond whether the PPT is visible or not.
Visible, sir.
Well, Nirmal, is it visible right now?
No, sir. It's white screen only, sir.
Rejoin, man. Disconnect and rejoin once.
Okay.
It is joined,
Yes, sir.
visible, Edgar?
Yes, sir. Transmission of data.
Okay. So transmission of data. So like I said, so there will be two things. So one will be a interrupt one, another will be the buffer. So they will use the buffer in order to transfer the data. So okay. So initially what it will do in the sense, it will check whether the buffer is empty or not to do the transmissions. If the buffer is empty means the transmission will take place. Okay. And it will ask the acknowledgement for the interrupt. So interrupt is used to transmission purpose, whether I want to transfer the first data or not. So once I receive the acknowledgement, okay, so the buffer will be empty. I will check. If it is empty, I will transfer the data. Okay. And again I will check whether the data which is available in the buffer, it is fully transmitted. I will check the buffer again. So again, if it is empty means I will wait for the interrupt acknowledgement. So I will send the request, that is the interrupt request, and acknowledgement is nothing but I am receiving okay, you can do the transmission likewise. So again I will put it in the buffer. So from the buffer that will be taken to the destination. So whether I want to write it in the sense any memory location from the buffer, I will write into the memory. Suppose I want to send the data to the display. So I will check whether the buffer is become empty or not. Okay. So once it is transmitted to the if I'm connected to the project in the sense once the data is transmitted means again I will put the next data into the buffer after receiving the proper acknowledgement from the processor. So this is how the transmission will be done. And the reception. So reception is quite opposite. So receiving operation, what I will do, I will check whether the buffer is full. Okay. Why? Because processor want to read. So want to read from the buffer. Okay. So if it is buffer is empty, no data is received in order to read. So what I will do, first I will try to get the data. So but once the data is placed, suppose I'm giving any input using the keyboard. Okay. I'm pressing the letter V. So after pressing the letter V, I will get that data into the buffer. So after that, the processor will read. So when it will activate in the sense whether the read operation will be activated when the buffer is full. If you go for the transmission purpose, I want to check the buffer is empty. Why? Because I'm going to do the transfer operation. So I will paste it in the buffer. I will send it. Okay. And in the receiver, it is quite different. I want to read something. So that what I want to do before reading, I require the data. So where I will put the data should be put it into the buffer. So once I receive from the buffer, then processor will do the read operation. So read operation is nothing but the receiving. Okay. So when the interrupt will enable the sense when the buffer is full, then the interrupt will be enabled. After that, the processor will do the read operation. So did you understood the transmission operation as well as the reception operation? So how the transmission will be done? Did you understood? This is the two basic operation. So transmission can be done by placing some data in the buffer, and after that I will send the interrupt. I will receive the acknowledgement and I will do the transmission. So once the buffer become empty, again I will do the next transmission purpose. So next data will be transferred by getting the acknowledgement. I will put the data into the buffer and I will send it. After that, the buffer will empty. Again, the interrupt will enable. So this is the transmission. In reception, I will check. So in your reception, I will check that any data is available or not. So once it is received in the sense, then only the interrupt will enable. The processor will do the read operation. Okay. So this is your receiver operation, and now just to see the pin diagram. So this is the RS232 pin diagram. So totally 9 pins are there, and the logical values, the ones and zeros can be given in reverse voltage. So it is a negative representative. So if you see that the logical one can be represented using -3 to -25 volt. So it is a negative logic. So it's not a positive logic. So positive logic means a positive voltage will be given to high logic level 1, and the 0 will be given to your logic 1 0. So 0 1 is there, right? Binary value. So 1 will be represented using the voltage 5, and 0 will be represented using the voltage 0. So that is a positive logic, but here they are using the negative logic. So negative logic representing 1, here it will be represented using the voltage, negative voltage -3 to -24, and as well as the 0 will be representing the positive voltage 3 to 25 volt. Okay. And so if you see the baud rate here, they given the maximum baud rate 2400, 4800, 9600, and so on. Okay, so likewise it will double, the baud rate will be doubled for RS 232 standard. And as well as check the pin, the first pin, so that is named as the data carrier detect. So data carrier detect means whether any thing is connected or not in order to represent. If you see, if you are using the TV, so smart TV, so if you connected any cable, it will show something is connected, so it will read. So in order to detect that one, I will use the data carrier detect. And wait, let me, I will show the pin here. So can you able to see the pin, right? And second pin is receive data. So I in order to receive something, I will use the second pin. And for transmission purpose, I will use the pin 3, and the pin 4 is used for data terminal ready. So listen, so there will be two things. One is a data terminal ready, and another is data connection connector terminal equipment. So data connector terminal equipment representing the receiver. So receiver in the sense it's not a computer, it's other devices like embedded systems, like a printer, like a mouse, like a keyboard. Okay, so data terminal ready is nothing but the computer. Okay, so these are the pins. So data terminal ready representing the computer is connected and it is ready. Okay, and the pin 5 is ground, and pin 6 is data set ready. So data set ready not to do the communication, I mean I want to transfer in the sense, first of all I want to make sure that data is available. So once the data is available in the buffer, then the data set ready will enable. Okay, I'm having the data, I'm ready to send. So after that only I will enable the transmission purpose, I will enable it. After that the data will be transferred. Right. Guys, 2 minutes. I will be back.
Guys, can you hear me? Hello? Is it
Yes,
audible?
sir.
Sorry for the
Yes, sir.
disturbance.
Yes, sir.
Okay. So we see now up to data set ready. And next is the request to send. So there will be a two control signal. One is a request to send and another is clear to send. Okay. So request to send in the sense, suppose I want to receive something, I will give the request option. Okay. And clear to send is to intimate that here I can able to receive. So you can able to send the data. So that is your clear to send. So I am just clearing the buffer. So buffer is used to clear and then you have to load the data so that if it is empty in the sense, it will send the control signal using the clear to send. Okay. And the ring indicator. So ringing indicator is representing suppose for calling purpose. So if you are connected to communicate between the microcontroller and the computer, suppose I want to make the communication, so there will be a ringing indicators in order to enabling if I'm while transferring the data, so like uh, suppose you are making the internet calls, right? So likewise, if I'm I'm making a call, this is you will get the intimation. So likewise, so in order to make the ringing indications, I will use this pin, ninth pin. So mostly they will use a maximum of 3. So one is your transmission data, that is a pin 3, and the received data pin 2 and the ground pin. So these are the 3 pins which majorly we are using for transmission purpose. So here you can able to see. So there will be a data terminal equipment, that is your TTE. So that is your computer CPU, and here you can able to see the data connector equipment terminal. So DCE, data connector equipment terminal. Okay. So how they are connected in the sense, they are using the 3 pins. One is your the second pin for transmission purpose, and third is your third pin for reception purpose, and seventh one is a ground. So common ground will be there. Okay. So they will connect each other and the communication will be done. Okay, so this is a connection diagram for your RS-232 using your the CPU, the computer, and this is how the pin look like. So I think you're now you can able to remember. So those who are can't able to remember the RS-232, so this is how the pin will be. And similarly, not only this, in olden computers, they will use a round pin for a mouse and keyboard. So now only they are using, everyone using the USB mouse and USB keyboard. And previously it was RS-232. So it looks like round one, and you can able to see the pin will be uh, arranged in circular manner, like a round shape. So up to this RS-232 is completed. So today we seen about the RS-232 and how the transmission will be done, how the reception will be done, and what are the registers they are using. Likewise, they be seen, and what is the and as well as the baud rate, and what the registers we are using, what are the different baud rates we used for transmission and reception purpose, and that and how the transmission operation will be done, how the reception operation will be done. Okay, so things we seen today. And so difference between the RS 232 and RS 422 and 485. So RS 222 and RS 485 used for noisy environment. So noisy environment means
RS-232 will be used for short distance, like you are using some kits which is connected nearby. The length of the cable will be 1 meter, 2 meter. So in that there won't be any noise. And if you want to transfer for a long distance, for example, maximum of 1,000 meters, you can't able to use RS-232. On the time I will use RS-422 or RS-485 cable. Okay, so in that standard, I can able to transfer the data for long distance up to 1,200 meters with less noise. Okay, and as well as they will use that twisted pair. So twisted copper pair they will use for communication purpose. You know what is a twisted pair, right? So twisted pair coaxial cable. So mostly coaxial cable used for a high frequency of signal. And here we are not going to use high frequency. So low frequency signal I'm going to transfer. So I'm using the a twisted pair cable. So that is a copper wire cable only. So there is a difference between your RS-232 with RS-422. Okay. And you can able to make the connections up to 512 devices. So 512 devices in the sense not only you are connecting one computer, one embedded systems or one microcontroller, I can able to connect up to 512 devices each other. And the mode of operation, the communication will be a full duplex or a off duplex. So you know what is a full duplex and what is a off duplex, right? So I can able to change whether the communication has to be done in full duplex or a off duplex. So maximum we will use a full duplex only, not to do the fast communication. Okay, so that is the difference between this RS-232 and 422 and 485. So RS-232 used for short distance, and RS-232 can be used for synchronous and asynchronous communication with less range. But 422 and 485, they will used for a long range transmission up to 1,200 meters, and I can able to connect up to 512 devices together. And here there will be options, so you can able to go for the full duplex or off duplex communication. So any queries? Guys, any queries?
No, sir.
So I will go take that attendance then. Today only 15 are present. Jayashree is outside.
Hello. Sir.
Yeah.
Hello. Sir.
Yeah.
Sir.
Who is this? Tell me, Jayashree.